First off, I want to let you know that this module is quite long and a bit dense. So if you feel the need to take a break midway, I recommend you do so. In this module, we will be reviewing the basics of OpenBIM concept and interoperability through the IFC format, all using ArchiCAD and Solibri. I want to clarify that these concepts are just the foundational concepts, as the topic is vast and extensive. My focus will be on covering the most concrete and necessary points so you can exchange information with other users and software. Review the videos at your own pace, and if something feels too fast, feel free to pause and go over the material as many times as you need. As always, keep an eye on all the resources I have uploaded for each lesson. Having said that, let's get started with the first lesson. Alright, so this is going to be a major one because we're going to comment about interoperability in general. Everything related to the industry foundation classes, in other words, how you can export from ArchiCAD into other software such as, for example, Navisworks, maybe Revit, maybe Solibri, maybe structural software. The idea here is how you can exchange information from ArchiCAD into other platforms and in between. And of course, what the industry foundation classes stand for, how you can configure this in ArchiCAD, and a bunch of other information related to this, okay? So this is pretty much the idea here. Keep in mind that since this topic is really complicated, it's a really extensive topic, we're going to focus for now on the basics, okay? That's why I want to make it clear from the very beginning, but not the extreme basics. We're also going to cover a little bit about how the IFC project manager works, how you can, in other words, take your ArchiCAD model and visualize how it's going to be translated into the IFC format. Configure everything related to the IFC translators, which translators you got for importation processes, which others you got for the exportation process, and of course, everything related to the conversion presets, how this stuff is going to work. How you can also, for example, map your IFC types in ArchiCAD. And of course, the testing part, the practical part. I want to make it clear we're not going to use Navisworks, neither Revit. I'll use this for demonstration purposes, only Revit. But for practical purposes, you don't need to install Navisworks nor Revit. So don't worry about this too much. But what we're going to use is another software called Solibri Anywhere. Solibri is completely free. You can download it in a really simple way. You just create your account and pretty much that's it. And it's a free software to use. It's going to allow you to, in first place, you export your model in IFC format, and then you can visualize your model if it was exported correctly, which information is annexed, which information is included, how the model tree is structured, which data is included. All that stuff you can review it using Solibri Anywhere. So you are completely sure that the model is correctly exported before we bring the information into another platform. So yeah, pretty much this is what Interoperability Basics is going to be about. We're going to focus on the OpenBIM standards and all the process that revolve around this standard. Alright, so let's start off with the first things first. What is this about IFC? Or we can get to know this as industry foundation classes, okay? As Building Smart defines, which is the main organization putting the highest effort into standardizing this type of format along different types of BIM software, Building Smart will define that industry foundation classes are a set of standardized digital descriptions of the built asset industry, and following also this type of ISO standard provides machine interpretability of information and thereby enables automation of workflows, which is also a vendor neutral and available to everyone. Okay, now to give you a quick idea or a quick example So let's say in a really shallow example, but also a quite basic and simple example, let's say that we have three different operating systems. We got the operating system provided by Apple, provided by Windows, and provided by Linux, okay? And let's say that each operating system will have its own text editor in order to create documents, text editor 1, text editor 2, and text editor 3. Now, these are completely made up formats. I don't really use Apple or Linux operating systems. I only know the one for Windows. But let's say that each text editor has its own separate format. Okay, if we are working in the operating system for Apple, it's going to have some type of extension called Apple. I'm not aware of the format that it's going to be available here, but let's say it's format number 1. Then we got in Windows the one which is provided by Microsoft Word, which is docx, something like that. And then in Linux we also got a third format which is going to be Linux, okay? If you try to share the formats, well, we're going to have some issues while trying to share the results to somebody else that has another operating type of system and another type of tool. Okay, so it's going to be a little bit messy. We try to share the formats from one operating system to another one, or the formats for the text editor from one to another one. Okay, what's the interesting thing here, we could say that we have a universal format for all text editors in order to be at least able to read the format, which is going to be the PDF format. Let's say that the three operating systems will be able to export everything into PDF. Windows is able to export into PDF, Apple is able to export into PDF, this one is able to export into PDF, and PDF format is going to be much easier because the operating system for each enterprise will be able to also read the PDF format. So pretty much this is what's going to happen with IFC. If we replace the names, let's say that in Revit we have the RVT type of format for BIM models. Let's say that maybe in ArchiCAD we have the PLN type of format, and let's say that in maybe SketchUp, just another example, we have another type of format, okay? But what the three different BIM platforms, also considering SketchUp a BIM platform, share in common is that they will have the possibility to export everything into the IFC format, and you can import the IFC into SketchUp, you can import IFC into ArchiCAD, you can import IFC into Revit, and vice versa. Revit is able to export in IFC, ArchiCAD is able to export in IFC, and SketchUp will be able to export in IFC, which is completely amazing. Now, of course, when you export into IFC, it's possible that some data loss will happen. So that's a thing to keep in mind. Data loss will always be present. This depends also on the importer and the exporter for each software. So some percentage of data loss will be present unless you configure this as best as possible. But the most important thing here is that now everybody is happy because everybody can share different types of BIM models and information across multiple types of platforms. If we go over here to quickly, just a quick example into ArchiCAD, let's say that I generate a volumetry over here. So I got a volumetry over here, but I need to share this model into Revit. Let's even create a quick door over here and maybe a simple window, okay? So the guy working on Revit will say, okay, I need to model another extra volumetry over here based upon what you already have over here. So I don't really need to modify this stuff because I just need to take measurements and base off my new design based upon this model over here. So what we can do, for example, in ArchiCAD, let's say guy number 1 generated his workflow in ArchiCAD. Now he has to share this BIM model with guy number 2, which is using Revit to also generate the BIM model. So what we can do in ArchiCAD with file, we can save this as, I'm going to save this in the desktop, and let's save this as an IFC file. Okay, I'm going to export visible elements. The translator is going to be Exactly. Let's see, we got something for Revit. Yeah, for Revit we got general translator. We can use, for example, Revit export for reference model. And let's save this model. So I'm going to export this in IFC. Let's say I got Revit over here. So in Revit, I need to model the second volumetry based upon the first volumetry generated in ArchiCAD. What we can do in Revit is, for example, do the same process. We can, for example, go over here to insert. We can link an IFC file, and I'll take the one I just exported from ArchiCAD. So open this up real quick. So as you can see, it's not going to export the model exactly because some data loss is going to happen in Revit. It's going to also manage everything as a single element. Now this also depends upon the different translators, but at least I'm able to visualize the 3D model in my own personal platform, Revit. And now what I can do is, for example, okay, so at least I got the model. Let's take a wall over here and let's model an extra volumetry based upon this element. Okay, this first element, let's create a door over here and I'll create another door over here. But let's say, okay, I really need to share this with guy number 3, who is responsible for the carpentry of the project, the furniture and all that stuff. So in Revit, the same will happen. What we can do is go over here to File, Export, and we can export everything as an IFC file. Okay, so I'll just take a minute, export this once again. And let's say that guy number 3, who's responsible for furniture, doesn't know how to use Revit nor ArchiCAD. But guy number 3 knows how to use SketchUp. So what's going to happen here is that in SketchUp, you also get the possibility to import or export IFC models. So for example, we can select the IFC we have exported from Revit. I had to do this twice. Let's see what happens. I'm going to export maybe, well, there it is, okay? So we have exported the geometry from Revit. For some reason, it didn't include the ArchiCAD geometry. We can also, for example, import separately, also mix up the geometry from ArchiCAD. And yeah, there we have it. So we have merged both models from ArchiCAD and Revit into SketchUp. And now guy number 3 is happy because he has a reference model where he can start modeling the carpentry for the project. So this is an interesting thing about IFC. Yeah, some data loss is going to happen, as you noticed, but it opens up also the possibility of working in an open manner in multiple types of platforms. So let's say guy number 3 is done. The same can happen over here. So he knows how to use SketchUp. Okay, I'll give you back the reference model. Let's export a 3D model, okay, into desktop, and I'll export this in IFC format, which is going to be test number 4. Let's export everything as an IFC model. And then let's go back to the root where we got the model. And in ArchiCAD, we can go ahead once again, merge. Let's do it in the ground floor. IFC file we got over here. Let's select the test number 4, open the file, and let's see what happens. And there we have it. So I had to switch to Revit back because in ArchiCAD for some reason it crashed. So the winner in this case was Revit. But the general idea here is that the amazing thing is that now everybody can work completely freely through the IFC format. And yes, sure, some software might be able to save in the format that other competitors, other software will use, for example, ArchiCAD, which allows us to export a project in SketchUp, in Revit. Let's say we open up the 3D view, File, Save As, and yes, we have the possibility to export the project. Right over here we got the SketchUp file, yes, and we also can find the Revit project file. This is because ArchiCAD as a software has a great and amazing interoperability. Okay, but the thing here is that not all types of software are able to export in our formats. Let's take, for example, Revit. Yes, maybe Revit has some great features, But one of the things I really dislike about Revit is that, for example, if we try to export this in a format, everything is really standardized for the ecosystem provided by Autodesk. You can export this in AutoCAD, the XF format, or types of format. What you cannot is when find anything related to SketchUp nor ArchiCAD. The only possible format is going to be IFC, which is possible to import into ArchiCAD or SketchUp, which is a standardized format. Okay, the same happens with SketchUp. For example, if we try to export this as a 3D model, maybe we'll find some formats compatible, such as, for example, AutoCAD, but we won't find the ArchiCAD nor Revit type of format. But a rule of thumb is that the golden rule is that we will always find the IFC format in a BIM software. And the thing here is that pretty much all different types of BIM software, doesn't matter if it's for 3D, 4D, 5D, 6D, 7D, or whichever other purpose, if it forms part of the BIM ecosystem or the BIM workflow, it's most likely that you will be able to exchange information in an open manner with other software through the IFC format, the industry foundation classes. So hopefully with this I could make it clear the amazing advantages of IFC format. So if you're working on ArchiCAD or you're mastering ArchiCAD and your buddy or your friend is working with another type of software, amazing news, you're able to exchange information with your partner through the IFC format. Alright, so I gave you a quick example about the benefits of IFC. As well recommended, Industry Foundation Classes. This is the name for the Open BIM concept. Okay, by Open BIM we refer to the possibility of exchanging information with other software or other tools or other agents. Okay, so the idea here is not to centralize everything in the own ecosystem for an enterprise, but be able to exchange information freely. And we also commented that Building Smart is the organization that is the head of standardizing this IFC format, this Open BIM format, in different types of tools, in different types of workflows. There are multiple organizations that are making all types of efforts in order to standardize a format, but Building Smart is going to be one of the main organizations, so you can review a little bit about what they do, what the concept of Open BIM does for us, or about Building Smart in 4 minutes, and also the latest updates to what's going on with the latest types of formats. Now, something interesting here and also something really important to keep in mind. Yes, you might be able to exchange information, let's say, from ArchiCAD. We might be able to generate a model, start modeling software, and yes, we might be able to import this information into Revit. But something really careful that we have to keep in mind is that we can always exchange information for reference views as a reference model. If you're planning to, for example, start your workflow in ArchiCAD, make the 50% of the model right over here, and then simply export this and then import this into Revit to continue modeling everything into Revit, it's not going to be the best decision ever, said from experience, because sometimes the client, the person who's the model you're generating for, will visualize that everything is done natively. So everything will also depend whether the client will ask for you the model in Revit, maybe in ArchiCAD, maybe in SketchUp, because sometimes the client wants to be able to edit the model in a really simple way. So maybe you're able to export the information from ArchiCAD to Revit, but it's going to be imported into Revit as a reference model, and the families will be extremely generic. They're not going to be imported or linked with native families. Yes, you can import the model from ArchiCAD into Revit to be able, for example, to extract and read all sorts of data. Maybe you will be able to, for example, take the modify, the measure tool over here to measure from this point to this point. Maybe you will be able to, for example, take some dimension over here to continue documenting at some degree the floor plan or the documentation. Yes, maybe you will be able to extract this information into a table for quantification purposes. But if you notice, maybe sometimes the thing here is that the information provided here inside Revit, it says that it's a direct shape. So that's a boomer, because sometimes the clients will want everything to be able to edit it as simple as it is. Maybe go over here to walls and be able to edit all the walls in general. But the thing here is that the information is going to be more for reference purposes rather than for edition. The same happens, for example, with a PDF file. Maybe you export from your text editor into PDF. The other software is able to read the PDF freely, measure everything, etc. But if you try to import everything back into the native software, into another native software, into another tool, well, it's not going to be converted automatically to the native tools. It's going to be something really generic. So keep this small detail in mind. It's not a great idea to get the idea of, okay, I'm going to start the model in ArchiCAD, and then now simply export this to Revit and you can continue without any issues. No, it's completely fake. Yes, you can export from ArchiCAD to Revit, but only as a reference model, unless maybe you configure the export to some degree. But it's always best to, if your client asks for a result in Revit, make sure you work the model from scratch in Revit. If your client asks for a result, the final result in ArchiCAD, make sure you work your project from scratch in ArchiCAD, and so on for all types of tools. Yes, you can always export everything as a coordination model, but for edition purposes is not going to be the best idea. Now, you can also notice, and if you notice, for example, in SketchUp, we had two different formats, for example, in SketchUp. The same happens in Revit and ArchiCAD. We get two different IFC formats. For now, we got IFC 2x3 and IFC 4. To give you a general idea, the difference between each format, well, IFC 2x3 is going to be the most adopted one, because this one has even more time in the market. It's much more likely that this is a format that is always going to be available in pretty much all types of BIM software or BIM tools, okay? If I remember in Revit 2017, that's when I started using Revit, we had IFC 2x3, but we didn't have IFC 4, okay? And yes, this is a basic format of IFC. You can, for example, export the geometry, no issues. You can export walls, doors, slabs, beams, columns, and all that stuff. It's going to have some limitations to surfaces, some limitations to information, but you can export the essential BIM model. And IFC 4 is an improvement, which is, we could say not so new, but relatively new type of format. These will have improvements into the type of information stored, the amount of entities, the amount of metadata that we can organize. In general, this is a more advanced type of format, and that is one which is going to work a little bit better with other types of tools. So in general, IFC 2x3 is the standard one, the basic one, which is going to be most likely available in pretty much all the tools. And IFC 4 is going to be available in major tools. It's a more advanced type of format, and indeed a better format to use. Which type of information we can add into IFC? Pretty much everything. We can add the whole 3D elements we got visible. We can add 2D information, most of the 2D information, not everything. And also we can link a bunch of metadata and properties into the IFC format. But pretty much each software will map the information from the native tool, the native database, into the IFC format, so other software can convert this into their own native environment, okay? If you go over here to the sites, I'm going to include pretty much everything we got over here, the different sites we got over here, so you can always review them with some time. We got these two databases over here, which are quite useful, quite handy. We got the IFC 2x3 type of database over here, and we got the IFC 4 database over here. So for example, right over here in this page, you can review what's IFC 2x3 about. You can click over here, alphabetical listings, click on entities, and right over here you can notice in the entities that we're able to map in this format are going to be around 653 different types of entities. We can map 2D curves, we can map alarm times, assets, blocks, and the list goes on and goes on. Okay, so yeah, you will have the possibility to map over 653 different types of entities. Now keep in mind that yes, the full format of IFC, the full extent is going to be this number, but maybe in ArchiCAD, maybe in specialized software, you won't see the 600, maybe it's going to be a little bit less. The thing here is that for example, if we go over here into ArchiCAD, file, interoperability, IFC translators, then we jump into some general format. Let's take maybe this one. We go then to type mapping, and we go to map IFC types for export, which is yes, I'm aware it's a whole labyrinth. You can notice over here in IFC type, we're going to be able to map certain types of IFCs, yes. If I keep opening this up, we got a bunch of different types. We're not going to have the 653 types, but ArchiCAD will take only the main elements in order to be able to map them accordingly. It's not going to be the whole database, but only the required entities, required types that are definitely compatible with the native tools in ArchiCAD. So yeah, keep in mind that each software will only use the required ones, not the whole database. Then we have also the IFC format, the IFC 4 format. If you're wondering what each entity stands for, you can always click over here. For example, IFC annotation. It's going to tell you, okay, an annotation is a graphical representation within the geometry. So this is what's going to be saved or mapped in this format or entity. Okay, and then you also got all the attributes that are included within this entity. So you can, for example, let's search maybe for a basic one, which is maybe IFC wall right over here. So IFC wall, the definition from the ISO standard, a vertical construction, usually in masonry and in concrete. Okay, this is the element that's going to be mapped. From definition from Building Smart, and yeah, we got the type of use definition. You can use this entity when you want to map this type of elements, and then you can also include this type of information within the wall, which is metadata and properties also mapped in certain specifics. Okay, yeah, this is a really complex topic. I don't want to delve into really specific or technical stuff, but the fun thing, the interesting thing here is that you can always take a moment, review what each standard or entity stands for, and give you a general idea of how the mapping comes forward. Okay, you also got the IFC 4, which is a more improved version of the IFC format. You can also, for example, click over here, alphabetical listings, and you can go to the English version, entities, and you can notice if in the IFC 2x3 we had around 653, in IFC 4 we have around 766 different entities. And the same will happen over here. You can, for example, search for maybe any type of entity. It's going to give you all the technical data. This is going to be IFC wall, natural language names, the owner, the change logs, the semantic definition, the attributes, a bunch of different technical data that is included within this element. Okay, so yeah, this is how in general IFC is going to behave, is going to work. You got entities, these entities will be mapped into the native tools. The native tools are going to be mapped into the general entities, and the general entities will be mapped back to the general software. So this is how the translation works, and this will depend upon each software to do the best. In one instance, to be able to export correctly the native tools into the entities or on the general IFC entities, and of course the importation process, which is a second process that will include also some data loss. Some data loss happens over here, but the better we configure the exporter and importer, the less data loss will also happen. Okay, but this is the thing with IFCs. As always, take a moment to review this information, and for the next lesson we can start commenting a little bit how Solibri Anywhere works and why we're going to use Solibri Anywhere and how we can get and install this amazing tool. Alright, so there are different tools that allow us to visualize an IFC model, especially an IFC model, which is going to give us an idea of how the mapping process was done, whether by ArchiCAD, by Revit, and if the elements were mapped correctly, if everything exported correctly. So we are completely sure that when we share the IFC model with somebody, that person is going to be able to import it without any further issues. Okay, there are a bunch of different tools that will allow you to visualize your IFC model, one of which is going to be Solibri, a Nemetschek company. You can visualize a little bit about what is Solibri Anywhere about. It's just a basic IFC viewer which has a lot of useful, interesting things happening over here. But the main important thing here is going to be the registration process, so we are able to download it. So let's click over here, register to download. Take some time, fill out your first name, last name, email, all the data that Solibri is going to ask for you. Make sure you fill out this properly. In my case, I'll simply log in because I already got an account. And once you got your account registered, simply hit over here, login, Solibri Solution Center, login over here. It's going to take you to the Solibri Solution Center where you're able to download different types of products. Okay, Solibri Model Checker is even a more amazing tool, which interestingly enough has been integrated within ArchiCAD. You also got design. And if you jump over here to model check, you can find the model check report and the design checker, which has Solibri power tools going on over here. So if, for example, I hit the design checker over here, it's going to give us that Solibri Insight design checker, which is exactly the tool that you can also download externally. This is quite an amazing tool that will review the model for design issues and all that stuff. For this case, we want to use the Solibri Anywhere tool. This is the one that will allow us to visualize if the IFC model has been correctly exported. Let's go ahead, download the tool. There it is. The download, well, it's going to measure around 400 megabytes. This depends upon the version of Solibri you're downloading. Let's give it a few seconds to finish downloading. And then let's hit run as administrator. Give it a few seconds to start the installation wizard. You can select the language, press OK, then hit next, review the license agreement, accept and next. Okay, specify the installation as installation location, next. You can specify in which type of unit you want to work. For this case, I'll keep it a English metric. You can leave this one checked, doesn't really affect that much. Then you can specify which types of files are going to be associated. If you notice, IFC files as the first ones listed over here. So let's go ahead with next, create a desktop icon, and everything's looking amazing. So let's give it a few seconds to finish installing. And once it's done, hit next. And yeah, we can also run Solibri in one click. So let's finish. Let's see what happens now. Let's give it a few seconds so Solibri opens up. Then you get an extra agreement, review it, accept, and then you got the Solibri Anywhere tool running perfectly. Okay, so you got a bunch of different sample models that you can open, that you can visualize. But the most important thing here, I'll just open up maybe office building. Let's see how this one looks like. There it is. So I'm just going to open up a basic sample model. Let's close this one and close this one. And there it is. We got Solibri running perfectly. So this is an IFC file that has been exported probably from ArchiCAD or Revit, I don't really know, but this is how Solibri looks once it's running. You will be able to import or to merge multiple types of files, to visualize them, to present them, measure them, whatever you want to do with these files. And then you're able to visualize a structure. You can review which metadata has been exported along the element. You can select each element, visualize location, quantities. Quantities especially quite useful to always make a quantity takeoff for the elements. And it's going to allow you to visualize in general how the geometry was exported. So as always, take a moment, make sure you register, download and install Solibri. And once you have Solibri installed, we can start with a series of different tests with a base model I'm going to provide you in a moment in order to export this in multiple types of format, visualize what's going to happen in Solibri beforehand, and then test the importation into Revit. Don't worry if you don't have Revit, doesn't really, it's not extremely necessary, but for this case, make sure you got Solibri. Alright, so for this lesson, I'm going to provide you with this model. This is the same model we have used in previous courses, especially in constructive solutions with ArchiCAD, where we managed to develop basic constructive pilot project just to test out composites, test out the constructive documentation, how you can filter out that stuff. So this is the same model we finished in one of the previous courses. I'm going to provide you the full version, the one which is in PLA format. Keep in mind that this project has been created in ArchiCAD 27. Once you open this up, hopefully in libraries you don't have any ongoing issues because the project will also include the libraries, okay? So before we even begin with really technical stuff, let's take a moment to comment a little bit about the basic way on how you can work IFC, how you can export your project, the best possible way. We also can export this in 5 different tests and then visualize how all these tests will behave inside Solibri, okay? So the easiest way before we even begin, just keep in mind this small detail, we got a cut section active. So this is definitely going to impact how it's going to behave in the exportation. For this case, I'm going to go ahead in the 3D cutaway setting over here, delete all the cut sections so we have the whole model, okay? So the easiest way, let's go over here to File. You want to jump into Save As, because right over here we usually have Interoperability IFC, but this is something we're going to comment in the upcoming lessons, how these different settings work. For this case, we want simply to go into File, Save As, okay? And in Save As, I'm simply going to create maybe a new folder called something like IFC ArchiCAD Tests, and in IFC ArchiCAD Test is where we will export everything, okay? You're going to save as a type. You can select whether it's going to be an IFC file. This is the one that we most of the times want to use, and also you can use the IFC compressed file, which is a basic IFC zip. Pretty much these two behave similarly, but the standard one is the IFC file. Once you activate this format, you will notice you get a bunch of way too many options over here that we can mess around, something we're going to do in a little bit. You got file name, okay, and then you got the first step is what do you want to export. This is where you can specify whether you want to export everything that is only the visible elements or you want to export the entire project. If you want to export visible elements, this means that, for example, if we create the same section we had earlier, which was something like that, we maybe take the model over here, maybe take this one and these objects over here, right click them and activate the hide selection option. So we hide the selection. If you proceed to save the model with only visible elements, of course, as the name implies, it will only export what's visible in 3D. It won't export the hidden elements on the code section and the hidden elements we manually selected and made sure that it's hidden, okay? But if you want to make sure that everything exports, even if you have filters on over here, you can proceed with the entire project, okay? So it's going to completely ignore the code section plane, it's going to completely ignore the ongoing filters over here, it's going to export the whole project, okay? You can also, for example, make a third type of exportation. Let's say we select the column tool over here, press Ctrl A to select all the columns in the project, right click and show the selection. So we got selected the columns. Even you don't really need to show the selection. You can, for example, show everything, but simply select all the columns or some elements in your project. So once you select the elements, once again, you can try out the save as function. And you're going to get a third option, which is the selected elements only. If you want to filter the project out in a simple manner, you can select a partial part of your project and go ahead and use the selected elements only for the exportation process, okay? Now you can even go further. For example, if I deselect everything and let's maybe once again save as the entire project, you also got the filter button over here, which is quite useful because it's going to allow you to, as the name implies, filter further your project into really specific elements, okay? In first place, you can define how you want to group your elements, whether it's going to be by the mapped IFC type, okay, or whether it's going to be by story, or whether it's going to be by layer, or maybe by element owner. Okay, so you can pretty much select whether you want to, okay, so my project got some beams that I really don't need. So how about we deactivate the beams and the columns and we only export furnishing elements, slabs and walls, because the structure doesn't really work well in Revit for some reason. We want to export only these elements. Now, if you remember in the previous courses, if you notice something interesting going on over here, in IFC beam, we can even, for example, select which elements, specifically talking, we want to export. It's even more interesting in columns. We got C1 and MP1. Because if you remember, well, in this model, if I select the columns and, for example, show the selection, each of the columns, if we select, for example, one column and go to the last parameter over here, which is the IDs and properties, it has a basic ID, C1. This is a structural element. Then this is a confinement element, which uses another type of concrete, lower resistance concrete, okay? This one is also a structural element, this one is confinement, and this one is structural. So they have different IDs assigned. So interestingly enough, what we can do is also, for example, filter out specifically which IDs we want to export and which IDs we want to keep. So let's say I want to only export only the structural elements in my project. I want to ignore the confinement. So for example, you can hold down left shift, deactivate the confinement elements. You can identify by the ID and it's going to export only the selected elements. So that's quite an amazing opportunity you get into the exportation, okay? So yeah, you can mess around with stories. You can, for example, okay, I want to ignore everything in the roof floor, but how about we only export the foundation floor? You can do so, simply activate, deactivate however you want. You can filter out by layers. So you got your different layers in ArchiCAD, and you can say, okay, how about we don't export everything or everything located in the layer pilaster, and we export everything else. So that's quite amazing, okay? So you got different opportunities, just a matter of messing around. Let's keep everything turned on. Well, I'll simply reset this in a moment. You can also, for example, filter out everything by structural function. So you can, for example, go ahead, select whether you want to export everything or you want to export only the load-bearing elements or the non-load-bearing elements. This is also possible to filter out, for example, if you select once again your columns and maybe select your beams, right click it and show the selection. So let's say the beams, we can clearly identify which are confinement and which are structural. So let's say these beams in this project are structural. So what we can do is, for example, if you remember in classifications and properties, we also get one extra filter, which is going to be the structural function over here. And we can define whether this element is going to be a load-bearing element or a non-load-bearing element. Okay, so you can set it by undefined, but you can always in ArchiCAD add the extra tag for each element. Okay, so you get this extra tag when you're exporting your project. Maybe for a structural engineer, you want to export this into Tekla structures or another type of software, whichever software the engineer uses. So it's quite simple with ArchiCAD with this by structural function operation here. This is quite a useful option. You also can go ahead with IFC domain. So let's export only everything which is an IFC element. If it's something as a IFC proxy, ignore it, or you can filter out everything by IFC furnisher. So everything that's mapped as an IFC furnishing element, it's not going to be exported. So as the name implies, you got a really strong and powerful and solid filter option over here, even if it's a basic option in quotation marks, not so basic, but quite also an amazing possibility. Okay, for this case, you can go ahead with the filter the project however you want, and then something extremely important is of course the translator. Okay, how do you want to map the native elements from ArchiCAD into the IFC file? How do you want to translate everything? Okay, you got a bunch of different predefined options from your ArchiCAD template. You can go ahead and simply select everything in a more general manner if you don't want to get into extremely technical stuff. If you want to export something specific for Revit, okay, I got my structure in ArchiCAD. Let's export this as a Revit structure export or Revit map export, or maybe Tekla structure, so maybe CI engineer export. Or you can go ahead with IFC4, which is a stronger format. You also got general formats such as general parametric export and exact geometry export. Now, this is something interesting because this one and this one will definitely behave a little bit differently. Okay, especially for example, if you got complex elements such as, let's show everything for a second. Let's take this wall and let's maybe isolate the wall. I'm going to show the selection. There it is. So if you remember in the previous courses, we created a multi-layer type of wall. This is a composite wall which will include the core, which is this hollow block over here. And then we got intermediary finishes and final finishes, a bunch of different layers going on for this wall. Okay, so yeah, this is a single element that is composed of multiple types of layers and multiple types of elements. If you proceed, maybe for example, you export the project using the general parametric export, it's possible that the multi-layers will behave as a single wall. It's going to be just a basic volumetry, something like that. If you want to export this the best possible way, maybe exact geometry export will make sure that the layers behave exactly as intended. Okay, so yes, be careful when using also the specific methods. This is something that we're going to review in the upcoming lessons where you can change the different parameters, but be really careful and mindful that each translator will behave differently. Okay, you can always go ahead into options just to visualize what is the purpose for each translator. So you get a nice description going on over here. Optimized for Binkley, IcoSim, Building Designer, general parametric export for general purposes, as many parametric elements as possible, okay, and exact in their boundary representation as a rep element, okay, because we also got different methods for how the geometry is mapped, one of which is the extruded type of geometry. This is a general parametric method. It's going to export the profile and the rail, okay, and the rep boundary representation will export everything as it's going to export everything in a more polygonal way, boundary representations, exactly as possible, okay. So the methods, of course, will change. Be mindful about this detail, okay. So you can review the different settings, the general settings that we might comment in the upcoming lessons, just the main ones, not really extremely technical stuff, but the main ones. So you can notice that this one is optimized in IFC 2x3, which model filter, which type of mapping, and units, and all that stuff, okay? So having said this, you can always go ahead, experiment with different translators. Usually, most of the time, we can go ahead and the ones we usually use are exact geometry, general parametric export, and of course the IFC4 formats. These are the most used. If you want to go ahead and test this out, feel free to do so. So having said this, let's test it out in not 1, 2, or 3 ways, in as many ways as possible. So I'm going to start off with the same model. This is going to be the whole model, okay? But let's test it out with the general methods, okay? The exportation is going to be the entire project, and the translator is going to be, let's start off with general parametric export so we can visualize what's going on with this one, okay? Let's name this test, okay, this is going to be full general parametric export. I'll just make sure that the naming is pretty much the same so we can identify which filters and options we used. Let's proceed, save, let's give ArchiCAD a few seconds. And then let's save the project once again. It's going to be the entire project, but in this case we can go ahead, visualize exact geometry export. So I'm going to name this once again. Okay, so it's looking good. Now let's test out something more interesting. I'm just going to create maybe a cut section over here, something like that. File, save as. And only the visible elements. Okay, I'm forgetting something. I'm going to select maybe this furniture, the whole furniture in my project, and make sure that I hide the furniture from right click it, hide selection. Let's hide this one manually. And in this manner, we filter out a little bit the project. So let's go ahead, let's make another test, which is going to be test 3. It's going to be visible elements and the exact geometry. Let's do it test 3. Visible and the exportation is exact geometry export. So this is going to be test number 3, the visible elements, exact geometry export. Sounds good. Okay, let's save this. Now let's create another type of filter, much more interesting filter. How about we delete the cutting plane? Okay, show everything. For some reason I'm getting filter. Okay, and let's select all the columns, and let's select all the beams, and let's right click it, show the selection. Okay, now let's select. How about we only select maybe the structural beams and columns, which is going to be this series of elements. Okay, this one, and maybe this one. So this is going to be the structural elements we got in the project, and we assign a simple tag classifications. Well, in first place, I'm going to filter out this a little bit better. Show selection in first place. Okay, there it is. Now let's select in an organized manner first off the columns. We go to classifications and properties, and let's use this amazing tag, structural function. So I'm going to say that I'm going to set this as a load-bearing element. Okay, press OK. Now let's proceed with the beams. Let's go to the settings, classifications and properties, and activate the structural function load-bearing element. Okay, let's press OK. So we have defined which are the main elements that form part of the structural, have a structural function. We can even activate maybe the 3D document we got over here, construction process, foundation. Yes, we got a foundation going on over here. So we might as well visualize this foundation and categorize this foundation. So what I'm going to do is maybe I'll show everything, delete the cutting plane. Okay, let's only hide everything except the foundation. In layers, I'll make sure I only activate foundation. I'm going to also select the foundation and categorize this as a load-bearing element. Okay, in structural function, let's assign this as a load-bearing element. Press OK. There it is. So it's looking good. Now let's go back to the finished model and let's use the filters a little bit. So how about we proceed into file? As it is, doesn't really matter, save as. Let's make it a 4, name it load-bearing elements, and it's going to be maybe parametric geometry because it's a more simple, more basic type of geometry. So let's proceed with the entire project, but we are going to apply a filter. Okay, we can proceed with by structural functions, the first filter, load-bearing elements only. Let's see if this one is going to work properly. So you can notice something funny going on over here. It's going to tell us, okay, it's going to only select 24 elements, one of which are IFC walls, IFC column, and beam. So it gives me the idea that it's going to export only the structure. Interesting thing. So we got filtered elements. Okay. Exact geometry. Well, since it's a more basic type of geometry, we can proceed with general, but since if you can notice over here, since the foundation is a complex profile and it has some type of template, concrete template going on the base, we might as well use the exact geometry export. Okay, so let's go ahead, load-bearing elements, parametric geometry, exact geometry, sounds good. Let's save this one. Okay, looking good. And now let's apply another type of filter where we might only export the confinement element. So I'm not going to do anything in the model. I'm simply going to use the filtered options over here. And let's maybe, how about we select, we deselect everything else. And simply by IFC element type, I can visualize which elements are the structural and which elements have the ID of the confinement. Okay, so we got the confinement elements which are marked as BB1, and the structure is C1, and the confinement is going to be MP1. Okay, so let's press OK. So we got filter elements. This is going to be called test 5, confinement, and this is going to be general parametric export. Okay, because it's simple elements, since they don't have a multi-layer type of geometry, we can use the general parametric export. So yeah, it's going to be a little bit better, but finally we can visualize how it behaves in Solibri. Okay, so yeah, let's proceed with the final exportation as it is. And then the important thing here is that you got your different tests already. So remember, this is about testing out in first place the exportation process. It doesn't necessarily have to be 5 examples in your case. You can try out 10 examples, 3 examples, as many as you want. Okay, so take a moment, make sure you export as many examples as you want from this pilot project. And for the next lesson, now we can get into the conclusions of how each test is going to behave inside Solibri. Alright, so once we are done exporting multiple types of tests that we are doing with ArchiCAD, let's visualize how they behave with Solibri. So let's open up Solibri. I got my demo model over here, but right over here you can hit the main menu in File. Simply go to File. It's going to give you the welcome menu where you can open files, all that stuff. You got the workflow, the general tabs you can click over here. You can activate file, model, checking, communication, information takeoff. For this case, we're only going to use these two, file and model. So file is where you can open the files, you can add models, you can mix them, you can close them, and model is going to be the visualizator itself, okay? So in this case, in file, what we can do is simply close the current model. If you, for some reason, have opened a project, you want to use the close option over here. It's going to, okay, we don't want to save it. Now in model, you don't have anything. It's completely reset. So in file, what we can do now is once again activate the open model button over here. So let's proceed and let's select the first exportation test, the first step test we did with ArchiCAD. We got IFC ArchiCAD tests. This is going to be the full project, but with the general parametric export translator. Okay, so let's go ahead. You can open multiple types of files. You can, for example, open the IFC files, but you're also able to open IFC zip, special types of files over here, even PDF files, which are sometimes have a 3D model incorporated. So everything's possible over here. So, but the main purpose is, of course, IFC. Let's select the full general parametric export, open, and it's going to open the project. Okay, you can visualize the status over here, ensure model disciplines and categories. Okay, let's press OK. We can go back to file. So yeah, you can even, for example, if you want to mix two models inside Solibri, you can proceed with add models. This is going to add a second model on top of the first model. So you can visualize both models at the same time. You can mix them. You can even proceed and save the mixed model in a new format. You got the possibility to close the settings for Solibri, how Solibri is going to behave. And of course, the possibility to go back to model. Okay, this is where all the action is going to happen. Okay, before we proceed to visualize the test, a few options, extra amazing options we got over here. You got the menu bar where you can, for example, you got the Ctrl-Z, Ctrl-Y to undo the changes, to redo the changes. Right over here, you got different types of navigation commands. You can even use the keys 1, 2, 3, 4. You can activate the pan command to move or drag the view. You can activate the spin command. With left click you can spin. You can walk, okay, which is going to allow you to use the arrows key to walk through your model. Or you can even go ahead and use WASD to make a walkthrough through your model, which is some type of virtual tour, okay? Yeah, and it even detects collisions, okay? You have the gaming mode where you can use the whole mouse to visualize everywhere, and you can use WASD to move around the model, okay? For this case, I'm going to stick with the basic navigation. You have the direct mouse navigation where you can simply use the middle mouse. This is going to activate the pan command, so you don't really need to activate anything here. Scroll down, scroll up, well, it's going to zoom in, zoom out, and you can also press shift and middle mouse button. It's going to allow you to rotate the view, okay? You also got different amazing tools over here. You have the possibility to visualize the info for a tool. You can select elements, you can hide them, you can create markups, you can measure elements, the measure tool. You have the possibility to create sections. You can create your model or set some elements to be transparent, okay? Then you got a bunch of tools for visibility, for how you want to display your elements. You can also filter them out by IFC element. You got the possibility to create different types of zooms. You can center the view. Okay, you can zoom in a little bit, zoom out, or you can zoom into some area. You got miscellaneous options such as the settings for the 3D, how it's going to render out. camera settings, background settings, info, performance, etc. Okay, so you might take a moment. I'm not going to cover in full detail Solibri, but you can always take a moment, pause the video, and review which parameters you can mess around over here in settings. And you got extra navigation options, one of which is the type of perspective. If you hit over here, you can switch from a 3-point perspective to a completely orthogonal type of perspective. Okay, so with this icon you can switch. You got the mini map, which is going to give you a mini visualization of the floor plan. Quite useful in some cases. And you got extra options for visualization purposes, which I'm not going to use for this case. Okay. You also got, you can, for example, select, activate the info over here. And then if you select with left click, maybe one element, whichever you want to select, for example, this wall over here, you got something called the model tree, where you can also start filtering out your elements by foundation, by ground floor, roof floor. So it's going to give you a quick structure on the project, the IFC structure, where you can also select your elements, the doors, you can select columns, you can select maybe walls. Okay, so inside the walls you can even open up the building elements part and select something completely specific. Okay, or directly in the model you can click, left click, select the element, and then if you activate the info right over here, you can proceed and visualize the different tabs. You got beam data, model, discipline, layer, names, types, the IDs, IFC parameters that we can always configure. You got location, you got, for example, quantities, which is going to give you the full measurements for this wall or this element in general. So yeah, you got a bunch of parameters that you can always review over here, how everything has been mapped, and you can proceed and visualize everything. Okay, so yeah, pretty much these are the main options you got inside Solibri. Quite amazing navigation options. Something extremely useful is, for example, the markup. You can proceed and create different types of markups right over here. Maybe create a 3D markup here, maybe add some type of text here, sample text. You can always use Solibri to review the model with your clients. Quite a useful, handy tool. I rather review the project with ArchiCAD in my personal case, but feel free to do so with Solibri. Okay. You also got, for example, sectioning. Sectioning is quite simple. You activate the sectioning, and then you simply hit left click on one reference surface, for example, this part over here, and this is where it's going to create the section. Okay, I've tried to maybe select the section and try to move this, but it's not going to allow me for some reason. But with this, you can create section views, visualize how your model has been exported, and yeah, pretty much that's it. Finally, you also can right click this. You can, for example, mess around with viewpoints. You can visualize this from the top, from the bottom, from the left, right, whichever viewpoint you want to activate. Right click, visualize multiple options. You got the possibility in sectioning to remove all the sections. You can toggle visibility for openings, for doors, for walls. You got definitely a lot of options that I'm sure that if you take a moment, experiment a little bit by clicking, unclicking, everything, it's quite simple to use if you're already really familiar with ArchiCAD. So hopefully this is a really quick and really concrete introduction to Solibri. We're just going to use the basics, so there's no need to worry about memorizing everything now, because we only want to use Solibri so we can visualize how the exportation process was done. Okay, as always, take just a moment, make sure you navigate a little bit in Solibri, and for the next lesson now we can start visualizing the different exports. Okay, so once we have tested out a little bit how Solibri works, I'm just going to reset the model. I think it's much easier if I go to File over here, hit the close button over here, press no, and then open the same model. Okay, so this is going to be the full project, general parametric export. Let's see how this one behaves. Okay, so yeah, so you can notice something funny going on over here. It's not going to export the intersections going on over here for some reason. That's interesting. Everything else looks okay, I guess, but we got some issues over here. Then we got some issues, especially over here. We got a really high issue. So from the first method, which was general parametric export, we could say that for complex intersections, multi-layered intersections, where we got multi-layer walls, multi-layer type of complex profiles, we still got some issues going on. Okay, let's see if we can create a quick section over here so we can see what's going on. Maybe activate the section and create a section over here. So the foundation, we got the template, the base of the foundation looking good, but it feels like, it actually did respect the intersections, looking good, but where we get issues are especially in the intersections. Okay, so what we can conclude from this general method is that it works generally well, but if for extremely specific elements or extremely complex elements, you might face issues. Keep that in mind. Okay, let's proceed to File, close the model, and let's go ahead and visualize the second test, which is going to be the exact geometry export. Hopefully this one works a little bit better. So at first glance, we can actually notice that it's going to export everything a little bit better. Yes, the model might be a little bit heavier. Let's see how much it weighs. Let's right click and properties for the first test project. This one is going to be weight 2.53 megabytes. Okay, and this one, right click it, properties. This one, you can notice it's going to weight a little bit more, 2.93 megabytes. Okay, so yes, we can say that the exact geometry is going to weight a little bit more, but it's going to, after all, work a little bit better if we are facing a really complex geometry or really complex intersections. At first glance, it looks amazing. Okay, let's create a quick section over here so we can notice what's going to happen inside the model, the project. And yes, it's looking much better than before. Actually, for some reason, it didn't export the terrain. That's interesting. We need to visualize what's going to happen with the terrain, but everything else actually exported almost perfectly. So you can visualize the different layers intersecting one with each other. And yeah, we got the multi-layers here. We got the multi-layers for the window frame. We got the multi-layers for the foundations. So yeah, it's exact geometry. If you notice, it's going to work better at the expense of a more sized type of file. But you can go ahead with the BREP methods. Going to work in general a little bit better. Okay, let's test out the next one. I'm going to go to File, close the file. Let's go to Open the model, and let's go with visible, only the visible elements, exact geometry. So let's see what happens here. So at first glance, yes, you can notice that it has somewhat respected the cut section in ArchiCAD, because if you remember with this one, we created a cut section, but you can also see that it's going to fully hide the elements as a complete entity. Okay, so it's going to cut away a little bit extra type of element here. Maybe it's going to cut a little bit extra over here. So yeah, it's going to filter out the cut section, and it actually did respect the furniture. If you remember, we selected the furniture, right clicked it, and made sure to hide it. So it also respected that. So you can proceed with this quick filter if maybe you only want to export 50% of the project. Create a quick section, and that's how you can also export 50% of the project if you're looking forward to something a little bit more limited. Okay, so it's looking good with the exact geometry. We don't have weird intersections going on over here, so that's good to know. Let's proceed with the next model. File, close, and I'm going to open the fourth model, the fourth test, which is only the load-bearing elements. If you remember, yes, there it is. If you notice, in ArchiCAD we had the whole project, but we filter out only the elements we classified with the load-bearing parameter. If you remember, it was this one. We select the element, and in structural function you can classify this as a structural element with this tag, with this parameter. Okay, so yeah, at first glance you can notice it's working perfectly. It's looking good. We don't get weird intersections, so this one worked perfectly. Okay, let's proceed with the next test. I'm going to close the model. Let's open the confinement. So if you remember, for this one, we made sure to only export the confinement through the selection of elements with a specific ID. And as you notice, it worked also perfectly. So yes, the filter works out. This one was a general parametric method. So if you notice, we don't have anything funny going on over here except the section plane I positioned accidentally. But let's go with info. Everything is looking good with the geometry. For some reason, yes, we get a funny thing going on over here because we get this extra intersection. This is going to be a whole column, and this is going to be a whole beam for some reason. So be really mindful with the general parametric method, because it's not going to take into consideration the subtraction of the volumes happening inside ArchiCAD. If you remember ArchiCAD, what's going to happen over here? ArchiCAD will automatically subtract everything for you. If I filter out the beams and the columns, if I say, let's say, for example, I take maybe this beam, right click it and show the selection, you can notice that ArchiCAD, by the priority of intersection, by the priority of the material, is going to automatically subtract this and this part over here. And if you export this in the general parametric method, consider that the intersections ArchiCAD or the subtractions ArchiCAD does for you are going to be completely ignored. So be mindful about this small detail. Okay, so for 5 quick tests, I think we got amazing conclusions from this. Hopefully it is clearer for you which type of method you want to use, which type of method you want to proceed with. The conclusion here is that the exact geometry works best for more complex types of elements, and the general parametric export is meant for really simple stuff if you only want to test out something quickly in a more lightweight way. Okay, and also the different filters we applied worked perfectly. So hopefully with these 5 different examples, it's clear to you how you can start now exporting your different projects, the different parts for your project, and interchange information from ArchiCAD into other software. Alright, so having commented the different ways on how we can export the IFC format into other software, I want to give extra emphasis on how we can export into Revit, because ArchiCAD and Revit both are the main BIM software, and if I'm completely honest, well, Revit does have a little bit of more international adoption than ArchiCAD. So let's take a moment, test out a little bit more how we can export a BIM project from ArchiCAD to Revit. Now, the most important thing here is to be extra aware, because when somebody asks for a project in Revit, the client, the person who is going to receive the project, will expect that all the families are as best organized as possible. So you got the list of families. So for example, you got all the families perfectly organized, perfectly structured, perfectly named. We visualize, for example, maybe the furniture. Well, everything is perfectly named. Okay. If you're expecting to generate an exportation from ArchiCAD, and once you import this to have the same structure as it would have been created in Revit? Well, it's not going to be perfectly possible to export this from ArchiCAD to Revit. So don't get the idea that maybe you can start the project in ArchiCAD and later on continue in Revit. As always, it's best to start a project in the software that you're planning to give the final result in. If the final result has to be in the Revit format, you definitely want to start from scratch in Revit. If the final result is in ArchiCAD format, start from scratch in ArchiCAD. So the thing here is that yes, you can import the model from one platform to another, but to some degree you're going to be able to edit some elements. To some degree you might confuse the visualization, but to be able to fully edit everything as it would be in the native software, well, that's another story. So you might as well consider that this is more for reference model. If you're planning to measure, to create quantity takes-off, to maybe document to some extent, to some degree, well, it's still possible. But to work the project as a native one, well, that's going to be a different story. So for this case, I'm going to create a new project inside Revit. Let's start from scratch over here. Accept. Well, this one is in Spanish, but same story, okay? Now in ArchiCAD, what I'm going to do, first off, how about we deactivate the cut-in plane, so we got everything visible. And now in ArchiCAD, you got different ways on how you can export the project into Revit. The first one would be you simply go over here, File, Save As, and the most direct one, I'm going to create a new folder besides the general tests that we created, Revit test, something like that. Okay, let's open this folder, and let's, instead of an IFC file, you also have the possibility to export this as a native Revit project file over here. You got the RVT type of file extension. So make sure you select this one, Revit project file. Let's name this as test number 1, Revit direct export, something like that. Okay, and then in options we can also hit over here to visualize a little bit about how you want to export your project, whether you want to export properties and classifications as properties. You can do so for everything or only filter out specific data. You can keep the hierarchy for beams, columns, curtain, wall, railing, stair elements. You also can define the units and also the version of Revit that you want to export the project in. Since I got Revit 2024, I'll proceed with 2024. You got 2025, which is going to be the latest available. Okay, well, in ArchiCAD 28. In ArchiCAD 27, this of course is going to change. So let's test it out. Let's create a basic exportation here, press OK, and save the project. So give it a few seconds. There it is. So this one is going to be the first test, save as a direct Revit project. Now, the second way on how you can migrate your project into Revit for a reference model, of course, IFC files, okay? And this is where we're going to create 3 extra tests with IFC. Let's proceed with the translator and let's test it out with the, you got multiple for Revit, specifically for structures, for map. In this case, since we got a general model, we might as well proceed maybe a little bit with the Revit export for reference model. We can test this out a little bit. If you only want to export the structure or a map model, you might as well check out these two over here. Let's export this as a Revit reference model, okay, the whole project, and this is going to be named test number 2. Now name this as Revit reference model, okay, Revit export reference model. There we go. So let's proceed, save the project. This is going to be test number 2. You might get a notification here, simply press OK. And let's do 2 extra tests. I'm simply going to export this once again as a IFC file, but this is going to be exact geometry, okay, the whole project with the geometry, which is the exact geometry export, this one. So we can visualize how it's also going to behave in Revit. Let's proceed to save. Press OK, there we have it. And let's do a fourth test, which is going to be parametric geometry, so we can also get our conclusions. So this one is looking good. Let's proceed and save the final test. Alright, so once we open up Revit, let's see now how it's going to behave. Let's proceed with the first test. I'm simply going to open the model. If you remember, the first test was directly in Revit. Let's proceed to locate the folder, Revit test, and it's going to be the test number 1, Revit Direct Export. Let's simply open. We can straight up proceed and to try out to open this model. Open the file, continue opening the file. Hopefully it doesn't freeze or crash or something weird. And yeah, at first glance it's looking amazing. We don't have any weird intersections going on over here. A little bit of some type of sectioning going on, but the geometry fidelity looks better, looks decent enough. In terms of levels, you can see that the levels have been translated correctly into Revit. So if we, for example, go into the view and maybe try to create a plan view from a floor plan, you can select one of the 3 different levels. So let's test out maybe the ground floor, how it's going to look. Yeah, it's looking decent. We can visualize the objects. So it's actually decent enough in terms of the exportation, but we got a major issue going on over here. If you go into the families, maybe for example, let's see, we got walls over here, maybe a basic wall, a curtain wall, or a stacked wall. Well, you don't see any type of wall over here. If you select one of these elements, you can see that everything, yes, it did export everything properly, but this is a direct shape, and the family integration is completely lost in this model. So that's a whole boomer. And sometimes the client, sometimes the one who receives the project in Revit, of course, will want to have all the families directly linked. So direct shape is good for some extent, but it's not going to allow us to edit all the parameters for the model, for the wall. We could say that it's the same thing as, for example, we maybe take the whole model in ArchiCAD, so you understand the feeling, okay? And you simply hit the right click and convert everything to a morph. So if we convert everything to a morph, we lose all the possibilities of editing walls, windows, doors, etc. You can still create floor plans, you can still create cut sections, but you lose pretty much all the parameters in ArchiCAD. The same thing going on over here in Revit. So that's the feeling inside Revit. But yeah, we still, for example, can maybe take the wall. We can, for example, override the category. Maybe the cut pattern, we can assign some type of gray color over here. Just going to take a few seconds. Maybe override this. Maybe proceed with some grids for the project. So yeah, you can still document this to some extent, but it's not perfect as you would start the project once again in Revit from scratch. So yeah, that's the thing. This is amazing for a reference model because you can visualize, you can create some quantity takes off to some extent. But yeah, since everything is a direct shape, well, that's a boomer. For example, this door over here, well, doesn't have any parameters, okay? So that's the thing. This is how you can export a project from ArchiCAD to Revit, but you also got some pros and some cons, okay? Now, since we commented the main way, let's see the differences with the other formats, if we get something a little bit better, something a little bit worse. Let's proceed with the second one, which is going to be the IFC file. I'm going to close the whole model and start from scratch with a template file, maybe metric multidiscipline, press OK. And now inside Revit, what we can do is, in first place, I'm going to deactivate the view. And in second place, right over here in insert, let's go to link IFC. Let's try to locate the file, which is going to be the IFC file, and then take the Revit export reference model, okay? Let's open this up, and there it is. So you can instantly notice that you get the grids. That's quite useful. If you select the model, it's going to select the whole element unless you press the tab key, and then you can select individual elements. But the thing here is that this is still a direct shape. The same will happen. You won't get the possibility to, for example, visualize everything divided in families, organized by families. So it's going to represent some issue. If you notice from the previous model, well, you got some type of polygons looking over here, which is some type of issue going on over here. Maybe for documentation, that's going to have some type of issue. Surprisingly enough, I can notice something interesting going on over here, but I'm pretty sure that this is from the Revit template. So yeah, it's not going to import the layouts, okay? In 2D, so surprisingly enough, we still get the grids with this IFC, but let's see what happens in 3D. In 3D, the shape fidelity remains pretty much the same. You can notice that you get some degree of textures. For some reason, it's not going to export the terrain. Now that's interesting. But the shape will remain intact. So if you're looking for a reference model with everything included, we could say that this one is also fairly nice, fairly decent. Maybe let's create a quick section over here. And yes, it's still allowing us to visualize all the constructive elements. So yeah, that's decent enough, but it's almost the same as the first test, which was in native Revit file, but now done in the IFC form. Now let's proceed with the third test, which is going to be the, let's create a new one once in first place. And now insert link IFC. This is going to be the exact geometry. So let's see how this one will behave, because the previous one was you select everything, you select only one shape, and it's going to select the whole model. We still need to explode it or divide it, okay? But in this case, this one, yeah, we still select the element, it's going to select the whole model, unless we press the tab key. The same happens here, direct shape, okay? In 2D you get pretty much the same. I'm pretty sure that this is going to behave exactly the same as the coordination model. Let's see if we get something different. So in 3D it looks pretty much the same. So reference model and the generic geometry export, the one which is exact, is pretty much the same. Okay, it's not going to switch that much from one or another. Okay, so yeah, this one also will work decently enough in Revit. Also, we get the, yeah, we still get the level, so that's good to know. Let's see if in plan views we can create maybe a floor plan. Right over here, so we get level 1 and level 2. But yeah, we still got an issue because actually level 1 and level 2 are from the template. It's not going to detect for some reason roof floor, foundation floor, and all the different floor plans. Okay, but yeah, fair enough. Let's proceed with the last test. Insert link IFC and the parametric geometry. Let's open this up. Oh boy, this one, from the looks of the floor plan, we got something weird going on over here, so that's an issue. Yeah, you can select the elements individually in this one because, yeah, you select only one element, and since this is a link, it's going to select everything. But you can still, with the tab key, select individual elements. This one also behave like a direct shape. And then let's see how it looks in 3D, because I feel like it's going to look a little bit more awful. So yeah, this is the one that we definitely want to avoid, because parametric geometry is going to also mess up the model in Revit. So you can notice it's going to export the openings literally as openings, as bounding boxes, and then the intersections here will have some type of issue. So yeah, just take a moment. If you have Revit for some reason, you can test it out. But finally, which are the conclusions that we can take from here? So if I'm honest with you, I think that this, the first test works great. the second one will also work great. And if for some reason you don't have these two, you can always proceed with plan B, which is the exact geometry. The one that you want to avoid is going to be the parametric geometry. But otherwise, if you want to export a model from ArchiCAD to Revit, I would highly suggest that you even go for the native export. You simply select the in ArchiCAD, you simply select the Revit project file. This one is as optimized as best as possible. And yeah, Graphisoft has made some effort to optimize everything from ArchiCAD as best as possible. Yeah, the conclusion is going to be the same. It's not going to be an utopia over here where everything is still edible in Revit. No, it's going to behave as a direct shape. So that's a boomer. You can always export from ArchiCAD to Revit, but everything will behave as a direct shape or intended for reference model or for quantity takes off. But if you're planning to continue editing the model in Revit, it's not going to be an amazing idea. It's still possible with a lot of effort, but I highly suggest that you never export if you're intending to continue editing the model in another BIM platform. If it's for editing purposes, the best thing is to always stick from scratch from one BIM platform to the other one, or either use ArchiCAD from scratch or either use Revit for scratch. So when we're exporting models into the IFC format, one of the main concepts to keep in mind is going to be how the model tree is going to be organized. This is just a general structure which is going to allow you to visualize or get a general idea which is the foundation floor, maybe the ground floor or floor. And interestingly enough, we can also configure this structure within ArchiCAD, which is going to facilitate the process to others. Okay, you can always go ahead in external software how you want to organize your model tree, whether it's going to be by floors, by maybe layers, by maybe elements, or by the original structure. But let's give it a quick view at how this will work inside ArchiCAD. So we have commented that in File, if you want to save an IFC format, you proceed with Save As an IFC. Same will apply for Revit. But now in Interoperability, right over here, IFC, this is a route where we can find even more options in order to configure everything related to the IFC exportation. You got the IFC Project Manager. Now this one is extremely important, something we're going to comment in a second. You can also configure your translators, which we already commented just in a quick preview, just in a general manner. You can configure local preferences, and you got also interesting options whether you want to merge something else or add extra information to an existing IFC model. You want to detect some changes to the IFC model. You want to update your current model inside ArchiCAD. You got miscellaneous options that we can always test out. For this case, let's proceed by opening the IFC Project Manager. Let's activate this one, and you'll get a really interesting window over here where you also get the model tree going on over here with the different options to manage the model tree. You got all the different parameters to whichever element you select that you can always edit, and you also got the possibility to go ahead and also assign great assignations, a little bit of more advanced stuff where you can also visualize your elements and manage them. For this case, let's simply focus on the first one, which is going to allow us to generate and assign the model tree. Okay, so right over here, this is where you will visualize or get a quick glance on how your IFC model is going to be structured. It's going to structure everything as a project, site, building, and then divide this by floors. Okay, if you, for example, select maybe one element, which is maybe this door over here, you will get the possibility, this depends, because you get one of which is, if you select this in 3D, it's going to activate this icon. If you select everything right over here, it's going to activate this other icon. Okay, and both of these icons work pretty much similarly. Okay, if you select a model over here, you can hit over here this icon, which is the show model selection in list and it's going to automatically locate which element represents this 3D model. Okay, so we can get an idea. Okay, this one is going to be classified as an IFC DUR, which is this one over here, and it's going to include all of these different attributes. Okay, in the different sets, going to include maybe nothing related over here, but it's going to include the name, the tag, description, height, width, predefined, etc. and with these types of IFC data. Okay, the same will happen over here. For example, if you want to locate some element, for example this one, you get the possibility to select something in the model tree, and then left click over here, show list selection in model, and it's going to locate that element in the 3D view. So this is going to give you a quick idea on how to navigate your model tree. Okay, for this example, what I'm going to do, maybe I'll take the slab and let's maybe add some type of different material. I'm simply going to override the slab. Let's make it some type of concrete, which is going to be this one. And let's maybe add a little bit of context going on over here. So maybe add smaller road going on over here. Okay, how about we add a few trees, maybe some type of, how about we add a basic tree, which is going to be maybe this model over here. Press OK. I'll add one tree over here, and let's add maybe another one somewhere here. Okay, just for test purposes, experimentation purposes. Okay, so let's say you got 3 different elements that are not included within the project. This is just a context, and you want to mark this as a context for whoever is going to import this model into their own software. What you can do, for example, here, if you notice, we got a general folder which is called site. We can take, for example, any element and organize this a little bit better. So, for example, we can take these 3 models and simply move this into a general folder. If you, for example, select these 2 trees, you can click over here, show model selection in list. It's going to select in the foundation floor and the ground floor the 2 shapes that represent these trees. Then you can simply take this left click, drag and drop into site. So interestingly enough, you now get a new folder besides building. It's going to give you a new hierarchy level, which is going to be the IFC building element proxy, just a generic model, which is going to be these trees over here. Let's maybe select this slab, and let's say that the slab is just a general element. Let's see, we can select this over here, and let's see, we can move this into building in another level. Okay, so we're going to get something different. We got in the site, it's going to include the general elements. Let's see, we can even maybe take this slab, drag and drop into the site. So we get in general some elements in this surface level, which are below the site. And then we got everything else in the building level. So as you can see, managing these elements, organizing them is going to be quite simple. For example, if you say, okay, some elements, for example, in the foundation floor, I want them on the same floor. Interestingly enough, it's not going to allow you to drag and drop somewhere else besides building or site. Okay, so that's the thing. But let's give it a quick test. You can also synchronize the list to model. If there are any changes for this model, it's going to update them. And finally, you can also list the visible model elements only or the whole project. You can also click over here to list everything. So with this small change, let's proceed to maybe visualize what's going to happen now. I'm going to close the IFC project manager. We're going to get back to that window in a second. And now let's proceed with another quick test. So I'm going to proceed with save as. This is going to be another test in the IFC ArchiCAD test. And let's export this in the IFC format. And now I'll create another folder, which is going to be the IFC modified models. So we know where we're exporting the modified models, okay? I'm going to export the entire project, and the translator is going to be, of course, exact geometry export, okay? And the file name is going to be test number 1, and the change that is going on over here is going to be simply the model 3 change. Let's name this like that. Proceed to save. It's going to tell us that some elements have built-in materials that do not participate in collision detection. Interesting. Let's see if maybe I'm pretty sure that maybe it's going to be these two elements, and yeah, we still get that issue. Maybe these two won't export. Let's see what happens in Solibri. Okay, so I'm just going to proceed with over here. I'll simply close the model I currently have. Close, no, and then let's open up the test. IFC modified model, test number 1. Let's open this up. So yeah, for some reason it didn't export 2 of the slabs I got in the project because it says that it doesn't participate in collision detection for some reason. A little bit weird for me, but okay. But you can notice that in the model 3 change, we can open a project site, and there it is. You can notice how these 2 specific objects now are in a separate folder object, okay, in a separate level. There it is, and everything else is in a separate level. So yeah, for some reason it's not exporting these 2. I'm pretty sure that if we experiment a little bit, like maybe test out solid element properties, we might find a fix for why these 2 elements didn't export. But yes, if you have an issue, ArchiCAD is going to tell you. But the main idea here was to simply test out the model 3. Now you know how you can start identifying different types of elements in ArchiCAD through the project manager, how the model 3 is going to work inside ArchiCAD, how you can create minor changes. As always, take a moment, make sure you test everything out, you visualize a little bit how this will behave, and now we can proceed with extra functions. Alright, so before we proceed, I don't want to leave anything pending, which was the issue we had in the previous lesson, because we exported the model and 2 elements were missing. But now you can notice that these 2 elements are being shown. So the question is, okay, how can you fix this, which was a fix? This depends on the building material, because some building materials in ArchiCAD, as ArchiCAD told us, they don't participate in collisions. These materials can be, for example, air. Air is a basic material, so we can deactivate the collision alert for the air material, so it doesn't trigger any alerts in ArchiCAD. Another example was, for example, the soil, which also wouldn't participate in collision detection. If for some reason you get the same issue that it's not exporting the elements, the fix is quite simple. Let's go over here, options, element attributes, and you want to go over here to building materials. So in first place, in the previous example, it didn't export this slab nor this slab because it had the same material, which was soil over here, soil, okay? Yeah, I switched the surface over here, but the material is pretty much the same here and here. But if you notice over here in the building material tab, right over here, soil, if you go to classifications and properties, you get this small specific option. Does this material participate in collision detection? If you turn this off, you're going to get the same issue I had in the previous lesson. It's not going to export this material. It's not going to consider it into the exportation. But the fix was, okay, let's check this participates in collision detection. Press OK. And now, when you try to export the project, I made the small issue here. I'm going to close the model in first place so I can override the model. Okay. And in ArchiCAD, I'll proceed to export the full project with the fix and save this, press yes, and there it is. You can notice now we don't get an alert saying, hey, 2 elements have been excluded. No, the whole model has been exported, even the materials that participate in collision detection. So you can notice we got the slab that is exported over here, and we got the other slab which wouldn't export in the previous example. And of course, we get also the model tree. You can notice we got the building, we got the two slabs, we got the two different trees over here, and we got the slab that we marked under the site folder. Okay, so take a moment, make sure you review the materials if you have anything that doesn't participate in collision detection. The good news is that now you know also how to fix it. Alright, so we have commented a little bit about the model tree. Now the thing here is that we can still use the IFC project manager to take this further. And how we can take this further? By configuring, by managing which types of data we want to include inside the elements, because we're not only exporting the graphical 3D and 2D element, consider that we're also exporting a bunch of metadata and properties or non-graphical information included within these elements. Okay, so for this example, I'm just going to take maybe the base structure we got over here. Let's select all the beams, let's select all the columns, right click this and show the selection. So if you remember in this example, we got some elements, well, in my case, we got some elements that have a different type of concrete mix, such as, for example, the structural elements, which are maybe this column here, this one, and this one. And then we got other types of columns, which are simply joist beams, confinement elements, all that stuff that will use a different type of concrete mix. In my country, the concrete mix is going to be measured by kilograms by square centimeter. Okay, for structural elements, we usually use 250 kilograms by square centimeter. Okay, if in your country they measure this in PSI, in maybe bar, feel free to always use whichever unit you want to use. Okay. And for this example, I want to specify something. Okay, so the structure, everything that I'm marking in red is going to use this type of concrete mix. And let's say that all the confinement elements will use another type of concrete mix, which has a resistance index of 150 kilograms or a compression index of 150 kilograms by square centimeters. Okay, in my country we say just F prime C, something like that, F prima C in concreto in Spanish. So feel free to specify whichever data you want. For this case, I'll go with this example. Okay, so what we want to do is, in first place, let's go to the IFC project manager, and right over here in the IFC project manager, you can almost instantly notice that in ArchiCAD, it will only display what's visible in the 3D view. So it's going to display only the beams and it's going to display only the columns. Okay, so if you hide something over here, the IFC project manager is going to update based upon what's been shown over here. If you deactivate this option, let's deactivate this. Yes, we get the whole project. But if you activate the least visible model elements only, this is extremely useful. And now you will visualize only the important stuff. Okay, let's select this important stuff. Let's select all the beams. And interesting here, you will notice you got a bunch of different categories for all the information that you can include. You will notice that we got a bunch of categories called piece set. This is what's standardized by the Open Beam standard, okay, following some ISO standard. Okay, so we're not going to be able to modify anything over here. We can simply delete this. No, it's not going to even allow us to delete this or rename this. The only thing we can do is maybe activate a parameter here or deactivate and then specify that parameter. Okay, you can always go ahead if you want to work with the standard. You can proceed and use any of these categories. Okay, but how about we maybe select everything for the beams and let's test out maybe in general attributes over here. How about we activate the description in first place and let's maybe include something like horizontal structural and confinement elements. I'll just include a generic description just for demonstration purposes. So this is going to be the value that is going to be included. This is the title of the value. This is the metadata. And this one, the marked in red, is the property. Okay. And finally, we got the type of IFC parameter, which is going to be translated into or mapped into. So this value is going to be marked or mapped as an IFC label, this one as an IFC text, this one as an IFC identifier, beam type unknown, okay? So yeah, the type is really important because this is how each software will convert the data and interpret each data, okay? Let's create a quick example. How about we can use over here the new button, okay? Let's hit new. And how about we create an extra folder which is going to be custom data, something like that. So in this window, you can notice create new, you can create a custom IFC property or a classification reference, which I'm not going to cover for now. But let's go with something basic, a custom IFC property. You got the property set name. You can use something that has been predefined earlier, so you can include the extra data in one of these standardized folders. Or if you want to create something completely new, let's test it out. Let's name this as custom data, something like that. And then you can input the property name, the metadata or the attribute that you want to name, which is going to be concrete resistance or the concrete compressive strength. In my case, I'll specify that everything is measured in kilograms by square centimeters. In your case, you can name this however you want, depends upon your country. The property type, this is where you can specify whether this data, it's similar to something we also reviewed in classifications and properties for ArchiCAD, where you can create single values, you can create a table list or a list of values, bounded values, numbered values, whatever you want, okay? I'll keep it simple for now. And then you got the value type, whether you want to use an IFC text, which is one of the most basic ones, or maybe if this is an integer data, you can go ahead with integer, boolean, identify whatever you want, whether this data is some type of measurement or any other type of data, okay? I'll keep it simple also. I'll go with IFC text so we don't find any issues. So yeah, it looks like it's looking good. Let's press OK. So yeah, we get the custom data over here. We get the new field. And now what we can do is select, for example, all the beams. I'll type in that this one is going to be 250. And then the bounding beams, if that's the correct name. I don't really remember names in English. But hopefully the confinement elements will have a different concrete compressive strength. Okay. So yeah, it's looking good for the description. Is going to be the same and the elements will change. Okay, let's do the same for columns. If you notice we haven't created anything here, the process is pretty much the same. You can select anything you want to modify, create a new type of data, property set name, custom data, the concrete compressive strength expressed in kilograms by square centimeters, single value, and this one is going to be IFC text. Okay, press OK. And then the columns will have compressive strength of 250 and the confinement elements will have 150. Okay, so it's looking good. And now let's maybe add extra property, which is going to be the description. And how about we maybe in description specify that this one is confinement. Okay, this one is going to be in the description structural element. Okay, this one is also, let's name this confinement. Let's fix this actually, confinement. And finally this one is structure. So we get an extra tag over here. And yeah, pretty much that's it. This is how you can start adding all the non-graphical information through the IFC project manager to your elements. Okay, and once you are done, what we can do is we close this window. Let's test it out by exporting this extra model. So I'm going to proceed, File, Save As, IFC element, entire project. I mean, no, not the entire project. We only want the visible elements because we only want the structure, okay? Exact geometry export, sounds good. And this is going to be test 3. Data, well, I'm going to call it like custom data, okay? Custom IFC data. Let's save the model. Once it's saved, now we can visualize what's going to happen in Solibri, okay? So in Solibri, as always, we close the previous model. We proceed to open the latest model. There it is. And now, where you can visualize the data, this is the important stuff. In Solibri, you want to hit right over here, make sure you activate info, okay? If you select maybe a column, this column over here, this is where you can visualize the main categories. Right over here, you got BIM data, which is going to be divided in identification, location, quantities, material realistic classification. You can notice that we got something interesting here, IFC standard properties, and it's going to include more data. So in BIM data, let's see, we get the description. Yes, we get the description. And in description, this one is structure, looking good, okay? Let's select maybe a confinement element. If I remember well, it was this one. And if I'm not mistaken, the description is also going to change. So yeah, this one is going to say confinement. So description is working properly. And now let's see if in IFC standard properties, other properties, you got favorites, custom data. Yes, you got other properties, and you got the new created group, which was custom data. So right over here, you can notice we got the concrete compressive strength, the specification, and the mapping is perfectly done. So we got 250 for this one, and for this one, 150. So there it is. The custom data works also properly, and everything's looking good. So yeah, this is how you can manage the non-graphical information for your BIM model, okay? And finally, but not least, I just want to explain an extra quick way on how you can add information to your model. So let's say maybe you want to specify information for these 4 elements. What you can do is also select the elements, go into the settings dialog, and in classifications and properties, if you minimize everything and scroll down up until IFC properties, which is the last segment over here, you can notice in IFC properties we get the description looking good, we get the new field looking good, but also you get this button more directly. So you can simply hit manage IFC properties over here, and for this window you can pretty much do the same what we just explained, but in a more accessible and faster manner. So you can manage everything directly right over here. So hopefully with this, it is clear to you how you can include metadata and properties for your IFC project. As always, take some time, make sure you practice these concepts as many times as you need. And now we can proceed with extra functions. Okay, so finally, but not least, we also want to experiment a little bit with the different translators, which is an extremely important part for the IFC exportation process. I'm going to reset the model back to its original state. Let's delete this, this, and this. Okay, something like that. Now in ArchiCAD, you can also go over here, File, Interoperability, we set IFC. We also already commented the Property Manager, where you notice how you can manage your model, but also you got something really important, which are the translators. Okay, this is going to define how your model in your native software in ArchiCAD is going to map the IFC model, which how the geometry is going to be converted, how the properties are mapped, which types of IFC elements are included, all that stuff. Okay, so let's go over here once again, interoperability, IFC, and the IFC translators. Okay, So in general, you get this window where you're going to get two different apartments, one of which is going to be the translators that ArchiCAD is going to use when importing a model. This means that if you're planning to import an IFC or open an IFC inside ArchiCAD, it's going to use these different translators. And then you got translators for the exportation process. This means how you can take your model and send it to somebody else, to Revit, to Tekla, to maybe Trimble Connect or whatever you want to use. Also, this is how ArchiCAD is going to export your model. Okay. Now you also got something interesting here. This small icon that means that this exact translator is the one that is set to be previewed. Okay. If you, for example, select maybe something else, set preview, or you can select this one, set preview, or set preview for this one. So the preview is simply, for example, if we take the general the exact geometry export, set preview, press OK. If once we open back the IFC project manager, it's going to visualize everything with the export translator we set to preview. Okay, so right now we got the exact geometry active with some parameters. The preview we get over here is with the translator we have active. But if, for example, I go over here to Interoperability IFC and IFC translators, and let's maybe take the IFC 4 design transfer view and set this to be previewed. Let's press OK. So it's going to change a little bit once we open back the IFC project manager, because now you can notice that maybe some different types of data will start appearing here. Maybe you get another type of data, you get different categories. So yeah, you can notice that instead of only one, we now get a bunch of extra options. So pretty much the set preview is also going to affect how the IFC project manager will display your model. Okay, so it's a small detail, but quite an important one. And then you got for each translator, you got the different settings that will affect the translator in general. Okay, you got the name, you got the description, you got general settings. For this case, how about we maybe take the exact geometry export, set this as preview, but let's create a completely new translator from scratch. Let's make this custom export, something like that. Okay, export, there it is. Okay, you can base your new translator from something, or you can set this as a new translator from scratch for export. Okay, I'm just going to use it for export. There it is, custom export. Once you set the custom export, you can also add a brief description, an optional field which is meant for specifying how each export method is going to work. For example, share precise geometry using breps, or maybe we select the general parametric export. This one is extruded. Okay, we'll also include this data and this data. Okay, so you can specify a brief description, and most importantly, in first place, you get the IFC schema. Okay, or the IFC scheme. So in general, you can set this whether you want to work with this basic one or the most standard one, which was IFC 2x3, which we already commented in the previous lesson where I explained that you got different schemes. 2x3 is the most adopted one and supports up to 650 something entities. Okay. And also you got the next generation of the scheme. You got IFC 4, which also supports textures, supports a more diversified array of data, supports even more types of geometries and all that stuff, and manages geometries in a different manner. But maybe some software will still have some issues with this schema. Okay, so you can select whichever you want to use. You also got a parameter, the model view definition. I don't want to get into specifics, but you can always click over here for more info about this parameter. and it's going to tell you that the MVDs are recommendations for which data and elements the IFC model should include, even extra guidelines and filters, which are also standardized. Okay, I'll keep it by default for this case. Okay, and you can set a custom name for the model view definition. But for this case, let's only focus for now on the IFC schema and also the conversion presets, which I'm also going to cover in a moment. Okay, so take a moment, make sure you check out the different translators you got by default. Don't forget, you can always create new ones, delete ones. You can also set the preview if you want to notice how each one is going to work. And finally, but not least, you can always export the translators as an external, or you can import them for use. And finally, you also have the possibility to import in the translator. So you can import a translator from an external file. So that's how you can always proceed. Alright, so let's proceed with conversion presets. Now, as I mentioned earlier, I don't really want to delve into extreme specifics because we're still covering only the basics for IFC. We're testing out a little bit the grounds here. But let's see if we can comment a little bit about these different settings. So yeah, you got just way too many parameters over here that you can always modify, but let's maybe comment the most important ones. So model filter, as the name implies, this is how your model is going to be filtered out through the translator. Something we already commented actually in the previous lessons, you can always export everything however you want, but you can also do so with the translator. This is where you can define if your translator is going to export pretty much all the 3D elements with annotations, with the Duran window views, or only export the construction elements, or only construction elements with zones, or you can even, for example, go further with the possibility to create your own preset. If you, for example, click the 3 dots over here, it's going to open a complete new window where you can configure this further. So you can create a custom filter. Let's name this as a completely custom filter over here. And then you can proceed how you want to export the 3D elements, if it's all elements, load bearing, non-load bearing. We already visualize what's happening over here. So I think you're familiar with this option. You can also select whether you want to export something only by structural domain, by map domain. Or you can also deselect or select which elements you want to include or exclude. So everything that is going to be mapped as a proxy, which is a general model, you can, for example, deactivate this and exclude everything which is a built-in element proxy. Okay. You can also select 2D elements to export, whether you want to export lines, text, labels, Dur window 2D views. This one is going to be useful, might as well consider. And you also got the compatibility of current process with model view definitions. I don't want to delve into this setting, related translators. Okay, let's leave it over here. So this is in general how you can filter your model using the translator. As always, you can create your own group and then configure the parameters. Press OK. Then you got something really useful and important here, which is how the mapping process is going to behave. So if ArchiCAD is going to map everything by elements, by classifications, or how the process is going to behave. So let's hit 3 dots over here. Let's see what's going on over here. And how about we create also a new map, which is going to be custom map, completely from scratch, a new one. Press OK. And then you can also set the compatibilities related and Z. Okay, I'm going to leave this aside for now. But the interesting thing is over here, map IFC types for export. You activate this window. It's going to go a level further. From here, we went here, and then it's going to open a completely new window. Yes. And the most important thing here is right over here. How do you want to map your elements? Whether it's going to be by element type or whether it's going to be for by a specific classification. So even here is interesting here in ArchiCAD is that you can create your own properties classifications. We already reviewed the section. You have it completely clear with expressions, properties, and all that stuff. And then also link extra IFC type to each classification. So if you set this to element type, what's going to happen? I'll include these two extra links over here, which has a predefined property mapping. Okay, well, this is general data, but the built-in IFC type mapping for ArchiCAD over here, this one. It's going to tell you that, okay, so by default, the ArchiCAD tool is beam. It's going to export this by default as an IFC beam element. Column as IFC column, wall as wall, shell as slab, roof as slab, slab as slab, and mesh as side. Okay, so this is where you can get the idea of how ArchiCAD by default is going to map your elements. It's in this amazing table, you can get a whole idea of how the elements are mapped, how library parts are mapped, and how the native tools are also mapped. Okay, so yeah, this is where ArchiCAD will behave depending upon which tool you used, if you set by element type. And then, interestingly enough, if you set this further by classification, depending on which classification system you're working on, let's say we got for now the basic classification system we got in the ArchiCAD template. Let's see, we got maybe some type of element which has a construction element. We can take maybe a beam over here, which is going to be a joist beam. Okay, and this is where you can set by parent the definition from in general by beams, construction element. Okay, let's go. Yeah, so okay, I'm going to exclude the parent. How about we take maybe joist and fully customize this? Okay, so you can say to ArchiCAD, okay, whichever element I classify by this classification, the joist classification, I can also even assign an IFC type and IFC type product. So okay, so everything I classify as a joist is going to be an IFC beam instead of an IFC building element proxy, because I want this to be fully converted. Okay, you can predefine any type over here, whether it's the predefined type is beam, joist, whatever you want to assign. Okay, and then you can also assign the IFC type product, which is the IFC beam type. Well, I'm not going to mess around too much over here. But the most important thing here is that the amazing thing is that you can create your own classification system, create your classification in ArchiCAD. Besides assigning properties to your classification, you can also assign the IFC type you want to map according to your classification. This is something I actually did when I tried to export my beam model for visualization in augmented reality with the use of another application called Gamma Aere. The thing here is that Gamma Aere in the older version used to color the elements depending upon the IFC type. So what I did is I created classifications, and then I use these classifications with the IFC type to correctly convert the ArchiCAD model into my Gamma Aere model, okay, into my Gamma Aere visualization, and it helped me out later on. So yes, this is a really detailed window, but quite an amazing one. The important thing here to remember is that you can switch how you want to map your elements by element type or classifications, and you also have full control with the use of classifications and the IFC type, which is completely amazing. Then moving on, if you press, I'm just going to close here, we also got geometry conversion, which is going to control how your geometry behaves with this custom exportation process. Now we commented we got two general methods, something I want to comment in a moment, but let's do the same example. I'm just going to create a one from scratch, custom geometry, which is completely new, easier to explain in this manner. So custom geometry, in first place, you can define how you want to convert your ArchiCAD elements, okay? You can export only geometries which participate in collision detection. Now, this is an issue we fixed earlier in another manner, because if you remember, in one of the tests, it didn't export two elements. So we fixed this by modifying a little bit the materials. But the second way to fix this would be, of course, unchecking this option. So it's not only going to export specific geometries. If you uncheck this, now it's going to export 100% of geometries. So this is a second way on how you can also fix your geometry, okay? Of export geometry of IFC type products. Well, I'm going to leave this unchecked because this is another filter, export gross geometry of elements. Now this is important because if you remember what ArchiCAD usually does is, for example, if you got a wall, something like this, and then you position a column inside the wall, what ArchiCAD does is that it will automatically subtract the volume of this column from the wall. If you maybe create a window which has or some type of opening going on over here, what's going to happen is that you get an opening here. So if you check the option export gross elements, it's going to export the wall as it would have no significant changes going on over here. It's going to export the wall as a solid operation never happened. So it's going to be a gross element. Okay, if it's a net element, it's going to take into consideration openings, subtractions, and everything going on in the wall. So small detail here, but export all gross geometry of elements. Maybe we can uncheck this so it export everything completely fully. Then export all model elements geometry as parametric with exception. We have here two main methods for how the geometry is converted or how the geometry is handled. You have BREP, or in other words, boundary representation. And then you got parametric, which have the extruded and revolved methods. So what's going on here, maybe I'll zoom out a little bit. BREP, what's going to happen is that it's going to export everything completely exactly as the model intended. So it's going to export everything exploded into faces, into nodes, into the boundary representation. Okay, so this is a line, then we got a line here, line here, line here, which will make a polygon. Okay, we got one polygon here, we got two polygons here, three polygon, boundary representation. And the extruded method, it's going to export something a little bit more simplified. It's going to export the profile of the wall, and then it's going to export the reference line information. And what's going to happen is that the software that creates the importation process is going to interpret, okay, so I got this info, the reference line, then I got this profile. Okay, so in order to reconstruct the geometry, I'll take this profile and I'll simply extrude it along this reference line. So I get the reconstructed wall over here. And as we already commented in the previous tests, when we tested the boundary representation method and the extruded method, BREP is going to be more precise, okay, but the file is also going to be heavier, okay, so keep that small detail in mind. The extruded method is more simple, okay, more intended for simple stuff, but the file is going to be really light. So we got pros and cons going on over here. You got two different methods, one of which is the extruded one, which is the reference line and profile, and the other one, if I remember, it was revolve. You got something like that, then you got your profile, and it's going to extrude everything in a radial manner, following reference line. So if you got you got two different methods, the revolved and the extruded. Okay, right over here it's going to say, okay, extruded, revolved, parametric, or BREP. Okay, or you can also go ahead, use this parametric, but for extremely complex elements, how about we proceed with the BREP model. So you can also use an hybrid method between the BREP and the model. So for example, simple elements such as walls, you can proceed with something simple. But if it's a complex element such as curtain wall, you might as well proceed with BREP. Okay? If you activate BREP, it's going to use everything as the same. Okay? But if you go with parametric, extruded revolved, if you go with exceptions, what's going to happen in solid element operations? We can set this specifically extruded or BREP. What's going to happen with junctions? Well, actually in junctions we can proceed with BREP. So in this manner we can fix the issue where if you noticed some intersections of the walls, some intersections for the parapets, we had some issues in the earlier tests. With this small parameter we might be able to fix this. But if I'm completely honest with you, I feel a little bit more confident if I set this to BREP. Everything BREP, even if it weights a little bit more. Okay, you can specify what's going to happen with your the origin for your IFC model, whether the IFC model is going to be defined by the survey point and project origin, by only the project origin, or only the survey point. So you can define here which data you want to include. Then you can go further by specifying the hierarchy for the more complex elements such as curtain walls, such as stairs, such as railing. So for curtain walls, you can convert this to a single element. It's going to simplify everything just way too much. I rather set this to keep hierarchy if you want to have the least amount of data last in the process. You got material preservation if you want to explode only when necessary or explode everything into parts, preserve materials. Preservation is not guaranteed. If I'm honest with you, if I want to preserve materials for really complex elements, I would go ahead and maybe experiment a little bit with explode only when necessary or even explode everything into parts so it preserves the material. So this is as detailed as possible. You can go ahead and even specify how your composite structures and complex profiles will behave, okay? Whether you want to split everything into different parts. So for example, if you got a composite wall which has a bunch of layers, maybe the core, the finish is going on over here, you can proceed and explode this into separate elements if you activate this option, okay? And then you can even classify each of these elements separately, okay? So yeah, maybe you can split this into parts, might be convenient, but once again, I'm not so confident about this one. We can test out first how it behaves as a single element, and then if it has some issues, you want to keep this separate, you can proceed with this option and separate your structures and complex profiles into extra parts, okay? Compatibility settings and related translators. Well, the most important thing here is the settings. So in general, this will define how the quality of your geometry is going to be impacted. This is where you can fix the issues with joints, the issues with materials, the issues with pretty much all the geometry in your project. So this is quite important to keep in mind. Just keep this small detail close by. Then you got besides geometry conversion, you got property mapping. This is something we already commented earlier, but you can also define how your properties are going to be mapped across your IFC elements. So for example, IFC beam will have available these properties, IFC column is going to have available these other properties, and so on. So you can, for example, create new properties for this IFC map. You can create other properties for this one. As the name implies, this is meant for metadata and properties. So yeah, it's going to take some time. I don't want to delve too much into the metadata and properties over here, but anything related to metadata and properties, feel free to always hit the map IFC properties to each IFC type mapping, okay? You also got data conversion. You can mess around a little bit over here, which type of data you want to export, whether classification, element properties, parameters and categories. Select the array of data to export, base quantity, space containment, space boundary. Yeah, you can also go ahead and mess around a little bit about with all types of non-graphical data. And you also got the unit conversion, whether you want to use everything in a metric system, imperial system, whether you want to hit over here, or you can even hit extra options and specify how the length, angle, area, volume, currency, time is going to be managed for your IFC model, okay? But the juiciest parts are going to be, of course, the type mapping, the geometry conversion. This one is really important, and also the property mapping. If you got a lot of non-graphical information, this is also really important to keep an eye out, okay? So yeah, pretty much these are the different presets that we can configure for the translators. I'm not going to test a new exportation for each unique parameter. As you notice, it's just way too many parameters. The general recommendation here, if you don't want to get extremely technical, don't stress out about this stuff over here. The good thing is that the Archicad template will offer us already multiple different presets pre-configured from the very beginning. So if you find something extremely useful for you, you can proceed with the general ones, which were exact geometry export and general parametric export, which you already noticed, one which is going to export your geometry in a boundary representation, and the other one you can export this in an extruded method, okay? But you now already understand which are the main differences, might be the main difference for each translator, okay? As always, take some time, make sure you review the different settings we got over here, and now we can proceed with even more options. Alright, so after the really long ride about the conversion presets and translators, let's finally but not least comment really useful options for exportation that might come in handy for changes, specifically for changes, quite amazing options. For this example, what I'm going to do, how about we test out the first one, maybe over here, File, Interoperability, IFC, and I'm talking about these three specific options. Merge to IFC model, detect IFC model changes, update with IFC model. We got an interesting option here, which is merge to IFC model. So how will this one work? So let's say, for example, you might filter out the structure in your project, show selection, and let's simply proceed to export this normally into an IFC model. I'm going to create a separate folder which is called extra options over here, and let's use this folder. So it's going to be the visible elements. The format is going to be exact geometry. Sounds good. And let's name this only structure, okay? And let's save the model. So maybe you export the structure. Let's proceed normally in Solibri. Let's say the person who reviews the model now will only open the structure, which is going to be the extra options only structure. There it is, okay? But let's say the one who reviews, hey, I'm missing for this model the foundation. So what's going on over here? So if you want to create a quick change to your IFC model, you can, for example, once again, show everything, but besides only selecting your elements, which are the structures, you can also select, for example, the maybe deselect. Let's select this one, and then let's select maybe walls. Okay, sounds good. Shows the selection, and now I'll carefully filter out these once again really quickly. Select the tool, press Ctrl A, and then manually select only the foundation, which are also these elements we got over here. And let's filter these out, show selection. Okay, so if you use this option, what's going to happen is that it's going to override the whole existing IFC model. But also what you can do is you don't necessarily, if you already know, okay, so I made sure to export the structure perfectly, I might as well only add the extra missing detail, which is the foundation. This is the only thing I'm missing. So I don't really need to select maybe the structure. I can only, for example, select the foundation. And with this option, we can combine this extra part into the existing IFC file. So proceed with file, interoperability IFC, and let's use the merge to IFC models. So we add the foundation into the existing file. Let's select only structure file. Okay, what we're going to export is only the visible elements with the same translator. Okay, let's proceed, open. So it's going to tell us, okay, so it's going to merge around 31 elements in one story. You can review the info here, but let's simply press select and merge everything into the building. So there we have it. Let's see how it behaves now in Solibri. I'll close the current model and now once again reopen the only structure model. And yes, there it is. So you can notice now it has taken the elements from the previous version, which was only the structure, and it managed to include only the foundation. So we don't need to start from scratch. If you make a mistake or you want to create a change, you can proceed and use the merge to IFC model option. Alright, and besides the possibility of adding key components to an existing IFC file, let's test out the other option we got over here, which is detect IFC model changes. Okay. How about for this case, since we already got the model of the structure completely exported in IFC, let's see if we can make it a small change over here. Maybe I'll take this foundation, extend it here, and maybe I'll take this one and maybe intersect it. It's going to be a really small but significant change over here. Let's see how this one behaves. So I'm just going to export the second IFC model. Let's say visible elements, exact geometry, only structure, which is a modified version. Let's save this one. Okay. Let's see what's going to happen with this option, interoperability IFC, and activate detect IFC model changes. Okay. So it's going to say, okay, use this word to detect the difference between two IFC files. It's going to specify only 2 times 3 IFC 2x3, okay? 2 different versions of a project model. Only the 3D elements will be considered, okay? Let's select the older version and the newer version. So let's select the older version, and now let's select the new version of the model, which is a modified version. Let's use the let's use the exact geometry import option, and then let's hit next. Save everything into embedded, press OK. IFC domain, element type, grouping. I'm not going to mess around too much with these options. Let's merge everything, press OK. Okay, so there it is. Yeah, it's not perfect. I think I missed an option over here. But the interesting thing here is that it's going to create issues depending upon the changes that you get with your IFC model. So it's going to mark what's new in your model viewport in green. It's going to create another issue in green. Then everything that is the same is going to highlight it. And then in red, it's going to mark the modified elements. So if you jump into the issue manager, right over here, you can select any issue, for example, maybe this one, and start visualizing what's going to happen, what was deleted, what's a new element, and what's been modified. So as the name implies, this one is really handy because you can compare the changes inside ArchiCAD. If you delete the issues, it's going to reinstate everything as was beforehand. Okay, it's going to mix the model into ArchiCAD. So you might as well test it out maybe in a new file, something that I missed. So in this example, I made a mistake because I had 3 models. I had the current model and the 2 models I imported into ArchiCAD. I'll test this function out a little bit better this time. A file, Interoperability IFC, and detect IFC model changes. Select the old version, select the newer version. Let's proceed with exact geometry import. Next, okay, next, merge, okay, continue. So yeah, you got definitely some process going on over here. So I only merge for some reason only the foundation, but right over here. You can start comparing the older version, the newer version, and everything is going to be marked with issues. Okay, so this is quite handy, especially for comparing the changes you create in ArchiCAD. Now, finally but not least, besides visualizing changes, you can also, for example, if you got an engineer who is working on a separate software and you only want to import okay, I really gotta select everything step by step. I'll select this in a moment. Let's delete the foundation, okay? So the foundation here is gone in my project, okay? Because the engineer who is collaborating with you said, okay, I'll make sure that I update the foundation in my own software. Here you go, and import this into ArchiCAD. So what you can do is, for example, use the file Interoperability IFC and update with the IFC model option right over here. You can select your structure, you can open this, you can merge the new elements from your IFC model, press OK, into embedded library, press OK, and there it is. It's going to add the IFC elements into your own project, which is quite useful if you want to merge specific parts from external incoming info into your own project. The thing here is that the elements, well, since I did everything a little bit too fast, the elements have been created as model elements in your geometry. You won't be able to modify them parametrically speaking. You might modify only the dimensions in general, but there it is. This is how you can combine an external IFC model into ArchiCAD. Just keep in mind that you also will find extra layers, IFC imported new, IFC imported old. You can always, if you want to compare IFC models, you can always play around with these options. And also the foundation that has been added as a new element, you can also mess around with this layer, okay? So yeah, these options which we just commented, these 3 options are more specific to an IFC workflow. If somebody else works in a separate software and you work on your own software with ArchiCAD, you can merge or add info to a model. You can compare 2 different models, and you can, well, if this one was external, this one is more of an internal function. You can update your own model with something external, okay? So this is how you can pretty much in basic and concrete way work with interoperability using ArchiCAD. If you notice, it's a really complex and really long and really interesting topic. It's going to take a lot of testing, but hopefully with what we covered, with what we explained, you can now start using the different settings we got inside ArchiCAD, saving your model, exporting this to Revit, exporting this to other software, so you can also collaborate with other people in a better manner. And as you may have noticed, exchanging information between ArchiCAD and other software is not only possible but can also be done in a straightforward and efficient manner. If you need something more specialized, you can always fine-tune the IFC translator to meet your specific needs and achieve the best possible result with the software. In the next module, we will dive into a different topic, photogrammetry and how it integrates with ArchiCAD. We will also be working with 2 additional programs, concepts that we will explore in due time. As always, take a short break before moving on to the next section, and with that, I'll see you in the next module.